Hey there, fellow cybersecurity enthusiasts. Welcome back to our channel. Today, we have an absolutely mind-blowing topic for you: CORS vulnerability with trusted null origin. It's a jaw-dropping revelation that you won't believe until you see it. So, let's dive right in. We can now log in using the provided username wiener and the password Peter. And now, we can see the API key for the wiener user, which is in the response of the GET request to the account details. Alright, folks, let's get this right. It's time to send the request to the repeater and have some fun playing around with those request headers, such as referrer and origin. As you might expect, removing the ID parameter from the referrer request header doesn't seem to impact the response. Now, let's try adding something in the origin request header, let's say null. Here's the thing: certain applications may whitelist the null origin to support local development. And guess what? The null value is then reflected in the access control allow origin response header. Alright, folks, let's move on to the exploit server. The JavaScript in the body initializes the request, specifying the HTTP method as GET. It sends the request to our vulnerable website at the account details page and sets it to be asynchronous, true. The REQ listener function serves as the callback mentioned in line 3. Once the response from our vulnerable website, containing the API key, arrives, this function gets triggered. Within REQ listener, this line redirects the location to a new URL, including this .response text, the data from the vulnerable site. This leads the user's browser to our exploit server. The specified URL ending with exploit holds our payload, which will be delivered to the victim later. The script in the body has been adapted from this page. It generates a cross-origin request containing the value null in the origin header, with a sandboxed iframe cross-origin request of the form. Now, we can store and view the exploit in the browser, which comes with Burp Suite. Here, we can observe a request from our Burp browser to the exploit path. As we scroll up, we find the script mentioned earlier in the response to the exploit path. It appears as a sandboxed iframe, performing a cross-origin request. Now, take a look at the request being made to our exploit server at the log path. Interestingly, the API key of the wiener user has been included in the value of the key parameter. Great news! The API key for the wiener user is a perfect match. This means we're just one step away from our victory. Now, let's smoothly navigate back to our exploit server to continue the process. We can now deliver the exploit to the victim. Now, let's take a look at the requests made to our exploit servers, exploit and logs paths. Within the access log, we've spotted the API key for the wiener user, which was sent in an earlier request from our Burp browser. Interestingly, there are some requests to the log path from a different IP address. These hold the API key of the administrator user. To make it easier to understand, we can utilize the decoder provided by Burp Suite. We can then submit the API key as the solution, and voila! The lab is officially completed.